This gearbox has an infinite number of gear ratios, which means you don't have to change any gears in order to change the speed of the output. So how does this work? And is this mechanism used in real life? So why would we want to have an infinite number of gear ratios? And what exactly does this mean? Let's take a look at the example of an automobile. Most vehicles today have an internal combustion engine that uses pistons. However, according to some sources, this is likely to change in the near future. Internal combustion engines produce the optimal amount of power at a certain RPM. Basically, when an engine is spinning at just the right amount of speed, it has the optimal amount of power and efficiency. Each arch on this graph represents the car going through each gear. This graph may look confusing, but what it's showing is that you need to change gears in order to go faster and faster in your car. But instead of changing gears abruptly, with this system, you could actually change gears continuously, so there's no abrupt change. So here I have a model of an 8-cylinder combustion engine. But did you know it's possible to actually change the output speed without having to change the speed of the internal combustion engine, or without actually shifting gears? This is possible with the very clever usage of a planetary gear set and an electric motor. Let's quickly review how a planetary gearbox works. A planetary gearbox has 3 sets of gears: a sun gear, 3 planet gears, and a ring gear. If I hold the ring gear and rotate the sun gear, you can see the planet gears rotating a little bit slower than the sun gear. But what would happen if we also rotate the ring gear? So in the back here we have the model of the combustion engine. So our goal is to change the output speed without having to change the speed of the combustion engine. And the magic for how this works is because of this electric motor. We're essentially creating a hybrid system. So what we basically have here is the sun gear, which is attached to the main axle of the combustion engine. The sun gear is meshed with the 3 planet gears, which are all tied together with the yellow planet carrier. And this is our main output shaft. And you can see here that the ring gear is actually a double ring gear. We can control the speed of the ring gear with this electric motor. And combining the combustion engine with the electric motor, we could have a continuously variable output. So let's actually see it in action. Let's turn on the model of the combustion engine, and remember the combustion engine will always be spinning at the exact same speed, preferably the optimal RPM. And you can see the yellow output shaft is spinning at a constant rate. But now let's see what happens when we adjust the speed of the ring gear. Notice how the faster we spin the ring gear, the slower the output becomes. Eventually we could bring the output to an exact stop. And now if we crank the speed even higher for the ring gear, we could actually put the output into reverse. And now if we decrease the speed of the ring gear close to 0, you can see the output returns to its original rotational speed. This system is very similar to an electronic continuously variable transmission, or e-CVT for short. An e-CVT is an intelligent transmission that has an infinite number of gear ratios. It can constantly analyze the vehicle's speed, road condition, engine power, and driver input. Then it could select the optimal and most efficient gear ratio for that precise moment. This model doesn't perfectly represent this concept, but it should give you a very good understanding of how it works. And it's incredibly satisfying to be able to precisely control the speed of the output. Thanks for watching, and I wish you the best in all of your projects.